Welcome to my video lessons. In this video I am discussing about the small signal amplifiers. Small signal amplifiers, that is here we are discussing about the amplifiers. So we are in a type of amplifier, and that is small signal. What is small signal we will discuss after discussing the amplifier. First, what is an amplifier? Here amplifier is an electronic circuit. It is amplifying the applied weight signal. It amplifying means it is increasing the magnitude of the signal without changing its frequency as well as the shape of the signal. That is the function of the amplifier. So basically it is an electronic circuit. If you see this block diagram, this is a amplifier circuit, amplification stage, that is the circuit. Here the input is applied, the whatever may be the weak signal we need to boost up, that is applied at the input of the amplifier, and we are taking the output from the amplifier. The output of this amplifier is has increased magnitude without changing its shape as well as the frequency of the amplifier. Generally, this amplifier to operate this amplifier is performing the amplification, right? What is amplification means? Whatever it is performing. Amplifier is performing the amplification. What is amplification? Amplification is a process. In this process it increases the magnitude of the weak signal without changing the shape of the signal as well as the frequency of the signal. That means it only increases the magnitude of the signal. Again, it may increase the voltage or power depending upon the amplifier circuit, whether it is a power amplifier or voltage amplifier, whatever it may be, depending on the circuit and the way it is designed. So this is amplification. See, to perform amplification, that generally to design a circuit an amplifier, to design a circuit as an amplifier, right? We can use either a bipolar junction transistor or a field effect transistor, or we can use an operational amplifier, op amp as an amplifier also. So in this video I am discussing about a bipolar junction transistor, right? Again it is two types, NPN and PNP, right. See here, for amplification, in this I am designing an amplifier with using BJT. This BJT should be operated it should be in the active region only. For amplification, the transistor should be in the active region. Now what is an active region? Already we know about the transistor. Transistor has three terminals: emitter, base, collector. These three terminals, with these three terminals it has three mode of operations, three configurations: common emitter configuration, common base, and common collector configurations. What is common emitter means? Emitter is common for both the input and output sections, and base is the input terminal, and collector is the output terminal. That is about common emitter. Common base means base is the common for both the input and outputs. Input is applied at the emitter, and collector is taken from the output is taken from the collector. Common collector means collector terminal is common for both the input and output junctions, that means collector output sections. Input here in this common collector, input is applied at the base of the transistor, and output is taken from the emitter of the transistor in the common collector configuration, right? Again, say that means it has input and output sections, input and output. For every transistor there is an input and output junction sections, right? In active region means both the input and output both should be operated in the not for active region. The input section should be forward biased and the output section should be reverse biased. Then we can say that the transistor is operating in the active region. Whereas what is saturation region means both the input and output junction should be in the forward bias. Collector cutoff region means both input and output both should be operated in the reverse bias. That means for amplification, and that means at the time of designing an amplifier we need to design the circuit such that the transistor should be in the active region throughout the input signal. This is the main condition to design an amplifier. We need to make the transistor, it should be operated only in the active region. In that region only it amplifies the signal. Again there is one more amplifier word, we can say faithful amplification. What is faithful amplification means amplifier is amplifying the applied input signal. That means amplifier is increasing the magnitude of the weak signal without changing the shape as well as the frequency of the signal. If it is performing amplifying like that, increasing the magnitude like that, then we can say that it is a faithful amplification. Here we will discuss the basic amplifier using BJT in CE mode. What is CE mode? That we discussed just now. In CE mode, emitter is common for both the input and output sections. So in CE mode, input is base is the input and output has taken from the collector terminal. This CE amplifier is the basic amplifier and it can be used as voltage amplifier. That means voltage amplifier means it is amplifying the voltage signal. That means whatever may be the applied voltage at the input, that is amplified by the amplifier circuit. That is called voltage amplifier. We have another power amplifiers also. Right. Before entering to that, our title is small signal amplifiers. Now we know what is an amplifier. It is an electronic circuit. It amplifies the applied weakest signal. What is small signal? See, amplifiers are classified based on different parameters, many types. So based on the signal, amplifiers are broadly classified into two types: small signal amplifiers and large signal amplifiers. That means based on the signal ranges, it is small signal and large signal amplifiers. So in this session we are discussing about the small signal amplifiers. Later we will discuss about the large signal amplifiers. And the CA is here, it can be used as a voltage amplifier. See, already I said one point that it should be operated in the active region. For amplification, the transistor should be in the active region. That is the region VBB is making this emitter base junction as forward bias, and VCC is for collector base junction as reverse bias. This is the basic circuit of CE amplifier, and you can see this circuit. See, R1 and R2 are the biasing resistors to provide the biasing, and here it is voltage divider biasing, and R4 is the emitter resistor. Here it bypasses the not bypassing emitter capacitor. There we can there is one more capacitor across the emitter resistor. That capacitor CE we can it is bypass capacitor, and the function of this R4 resistor, or we can mention it as RE, emitter resistor. The function of it is to provide the thermal stability. And C1 is the coupling capacitor. It blocks the DC signal and it allows the AC signal, whatever may be applied at the input, it passes that to the base of the transistor without changing the Q point. the function of the amplifier we will see. Just now we see amplifier is the basic circuit, and here input of the amplifier is applied at the base. The output is taken from the collector of the collector terminal, and emitter is common for both. Just now circuit R1 and R2 are the voltage divider biasing resistors. RC is collector load resistor used to develop through output signal. RA is the emitter resistor. RER, R4, and Q1 is the NPN transistor. C1 and C2 are the coupling capacitors. Now we will see the circuit operation, how it is amplifying. See, the sinusoidal signal, the weak signal that is in the form of sinusoidal, it is applied at the base of the transistor. When input voltage is applied, suppose consider for the positive off cycle. For positive off cycle, the input voltage is increasing, positive voltage it is increasing. With the applied voltage, increasing voltage, the base current is also, the input current is also increasing. Now already we know the relationship between the IC and IB. Here IC is beta times of IB. The relationship between the IC and IB is beta times of IB. For positive off cycle, this beta is increasing. For positive off cycle, this beta is IB base current is increasing. What is beta here? Beta is a amplification factor. It is a very high value, right? For positive off cycle, this base current is with the increased input voltage, the input current is also increasing, that is base current is increasing. The base current is increasing means here the collector current is also increasing. The collector current is increasing means the drop across the RC resistor, that is ICRC. The drop across the collector resistor ICRC is increasing. The drop across this resistor is increasing means we know the formula. This V0, that is VCE, collector to emitter voltage, that is the output voltage, it is equal to VCC minus ICRC. VCC minus ICRC. Here for positive off cycle, this factor ICRC, that is the drop across RC is increasing. That means V0 decreases. V0 is decreasing. V0 is decreasing, right? That means we are getting that is the reason. If you see in the first block diagram, the output is 180 degrees out of phase with the input signal. For positive off cycle, for the applied input voltage, the base current is increasing. With that, the collector current is increasing. With the increased collector current, the drop across this RC resistor is also increasing. So the output voltage is decreasing in the positive off cycle. Next, come to the negative off cycle. When the negative input signal is applied, means it decreasing the forward bias voltage. That means the input current is decreasing. That means IB is decreasing. When the IB is decreasing, that means the collector current is decreasing. That means the drop across ICRC, collector current is decreasing. That means RC also decreases. So V0 increases for the negative off cycle. That means here we are getting a positive voltage. For the negative off cycle, for the positive off cycle, we are getting the negative signal, and for the negative off cycle, we are getting the positive voltage. That is the reason it is increasing the amplitude, but there is a phase reversal, and here it is 180 degrees out of phase. The output of the CE amplifier is always 180 degrees out of phase with the applied input signal. This is about CE amplifier. What is CE amplifier means? It is a common emitter basic amplifier circuit. It can be used as a voltage amplifier. Right, here common emitter means emitter is common for both the input and outputs, and the input signal, that means whatever may be the weak signal we need to amplify, that is applied to the base of the transistor through a coupling capacitor and the output is taken from the collector of the transistor through again a coupling capacitor. Generally it is isolation, that means here is also it blocks the DC and it allows only the AC signal to the next stages. It is amplifying the signal weakest signal, and it is magnifying the applied input signal. Now what is a gain? Amplifier gain. What is a gain? Here in the for this amplifier we are applying the input and we are taking the output. This gain gives the relationship between the output and input. Generally gain of an amplifier is a ratio of output to the input, output signal to the input signal. Again see, amplifier is amplifying the signal, so this gain describes, that means specifies how much it is increased. Generally we know the meaning of gain. Gain means what we got, what we right. The here is output signal to the input signal, what we have given and what we got. This gain describes that. Again see, there are three types of gains: voltage gain, current gain and power gain. Gain is output by ratio of output to the input signals. See, what is voltage gain? Voltage gain means gain is output to out to the input. So voltage gain is the ratio of output voltage to the input voltage. Generally it is specified by A is capital with subscript of V. V is indicate, A is indication for gain and V specifies the voltage. What gain it is means it is voltage gain. So voltage gain is the ratio of output voltage to the input voltage. It is equals to V out by V in. And the current gain, it is indicated with AI. A is gain and I is indicating the current. Output, it is the ratio of output current to the input current. And the power gain, here also we can say output power to the input power, but generally it is power is equals to voltage into current. So power gain is equals to AV multiplies with the AI. Voltage gain multiplies with the current gain. Generally power is equals to VI, so power gain is equals to voltage gain into current gain. See, here gain is the ratio of output factor by input factor. So here gain is a unitless factor, unitless value. Voltage and voltage, current and current and power. So there are no units for the gain. See, in the previous diagram we have seen the CE amplifier circuit with R1 and R2 resistors, RE and CE bypass capacitor. RE is for thermal stability, RC is the collector resistor to provide the output, and C2 is the coupling capacitor, and RS is the source resistance. And that means the input signal is applied to the input of the base of the transistor through source resistor and coupling capacitor. If this coupling capacitor is not provided, C1 is not there, means the input resistance is added with the R2, That means generally the R2 is a old biasing cycle, biasing resistor. That means the resistance will be added here. That means this biasing will be fluctuated if C1 is not there. And in this common collector circuit, this is a common collector circuit. And the common collector is common for both the input and outputs, and input is applied to the base of the transistor. Collector output has taken from the emitter of the transistor. Emitter at the output is across the RA resistor. Right, this is about common collector. In this, collector is common for both the input and output sections. And common base circuit, here base is the common and input is applied at the emitter and output is taken from the collector. And this is about the these are the circuits of CE amplifiers, CB and CC amplifiers. And these the hybrid models, that means H parameter models for CE, CB and CC, small signal circuits. See this, the first one is the CE amplifier. CE amplifier, the transistor is replaced with this equivalent circuit. HIE in series with the HRE-VC, HFE IB in parallel with the 1 by HOE. And the input is applied at the base and output is taken from the collector. Emitter is common for both the input and outputs. See, we know the H parameters. H parameter as V1 equals to H11 I1 plus H12 V2, and I2 equals to H21 V1 I1 plus H22 V2. So for common emitter, VB is the input voltage, V1 that means VB is the input voltage, IB is the input current, and VC is the output voltage, IC is the output current. And the what is HIE? HIE is the input impedance. It is the ratio of input voltage by input current. That means when VC is short circuited, when VC is open circuited, when VC is 0, HIE is equals to VB by IB. HIE is equals to VB by IB, and when IB is 0, HRE, RE, it is the reverse voltage gain. HRE is the reverse voltage gain. It is equals to VB by VC, VB by VC. See, generally gain is output by input, but here it is input VB by VC. VB is the input voltage and VC is the output voltage. That is the reason HRE is the reverse voltage gain. See this to H parameter representation of an amplifier. This is the transistor amplifier, V1 and Vout. Generally the H parameter equations are V1 equals to H11 I1 plus H12 V0, and I0 equals to H21 I1 plus H22 V0. What is H11? H11 is input impedance or input resistance with output short circuited. That means when V0 is short circuited, that means when V0 is 0, the input impedance, that is HI, is equals to HIE, H11 or HIE, it is equals to VI by I1. V by I, that means for HI, the units are ohms. Similarly for H12 is equals to VI by V0 when I1 is open circuited, when the input current is open circuited. When the input is open, that means there is no input, then that day we H12 is equals to input voltage by output voltage, that is it is the fraction of output voltage at input with input open circuited, with input voltage open circuited. This we can call HR. H12 can be indicated with HR with the input open circuited, this we can call reverse voltage gain. Input voltage, it is the ratio of input voltage to the output voltage, so it is reverse voltage gain. It is an unitless parameter, there are no units for reverse voltage gain. And H21 is the ratio of I0 by I1 when V0 is 0. I0 by I1 when V0 is 0. Ratio of output current to the input current, that means it is gain. It is forward current gain. This H21 is can be indicated with HF. This can be called forward current gain. Forward current gain or forward current ratio or current gain with output short circuited, that means when V0 is 0. I0 by I1, that means there are no units. Next H22 is equals to I0 by V0. H22 is equals to I0 by V0 when I1 is open circuited. That means when there is no input. It is the ratio of output current to the output voltage, that means it is an output parameter, and it is a ratio of current by voltage, that means admittance. Output admittance with input open circuited, that means when IA is 0, H22 is equal can be indicated with HO, output admittance. Here you can see H11 is equals to HI, input resistance or input impedance. H21 is equals to HF, short circuit current gain or forward current gain with input output short circuited. And H12 is equals to HR. H12 equals to HR, reverse voltage transfer ratio or reverse voltage gain with input open circuited. H22 is equals to HO, output impedance. These are the equivalent circuits, H parameter equivalent circuits for common emitter, common base and common collector. And these are the H parameter equations for CE, CC and CB. For CE, it is VB is equals to HIE IB plus HRE VC. IC is equals to HFE IB plus HOE VC. What this E is indicating? The subscript of after first parameter, the second subscript is indicating the mode of configuration, whether it is emitter or collector or common base configurations. So if you see the CC amplifier equations, hybrid parameter equations, the input for common collector is common, the input is applied at the base, that means the input voltage is VB, input current is IB, and the collector is taken from the emitter, so the collector current is VA, IE, and collector voltage is VA. With this, the H parameter equations are VB equals to HIC IB plus HRC VE. Next, IE equals to HFC IB plus HOC VE. For CB, base is the common terminal and input is applied at the emitter, so input voltage is VE, input current is IA, output is taken from the collector, output current is collector IC, and output voltage is VC. With this, the hybrid parameter equations, H parameter equations for common base is VE equals to HIB IE plus HRB VC. IC is equals to HFB IE plus HOB VC. These are the H parameter equivalent circuits for common emitter, common base, common collector configurations, and these are the equations Small signal analysis of a junction transistor. Now we will see the analysis of a transistor. Up to this part, transistor network with proper biasing, there is the circuit already we discussed. V1 and V2 are the parameters. That means input and outputs for the amplifier circuit, and the signal is applied, that Vs is applied to the circuit through the Rs, and Zi is the input impedance seen into the circuit, and I2 and V2 are the output and output current and voltages. IL is the load current, RL is the load resistor, output Y0 is the output admittance, and this is this circuit is replaced with the H parameter equivalent circuit with HI in series with HR V2 and HF I1 in parallel with the 1 by H0, that is the parallel resistor. And the equations of current gain, voltage gain, input impedance, output impedance of a transistor amplifiers are: AI is equals to minus HF by 1 plus H0 RL, and AIS, current gain in consideration with the source resistor, it is equals to AIRS by Z1 plus RS. AIS, current gain with source resistor, it is equals to AIRS by ZIRS. ZI equals to HI plus HR AIRL, it is equals to HI minus HF HR by H0 by plus YL, and AV, the voltage gain is equals to AIRL by ZI. AVS, what is AVS? Means voltage gain with source resistance, that means it is equals to AVRI by ZI plus RS, it is equals to AIS RL by RS. And Y0, output admittance, it is equals to H0. H0 is output H0, it is output admittance minus HF HR by HI plus RS, it is equals to 1 by Z0, 1 by Z0. AP is the power gain, it is the multiplication factor of AV into AI, it is equals to AI square into RL by ZI. See how we got, we will discuss the, we will get these equations in the next session, in the next video we will describe. Now for that, AI, AV, that means voltage gain, current gain, and the input impedance, output admittance, and the power gain are the parameters for the transistor amplifier in terms of H parameters. Formulas for AI, AV in terms of H parameters. CE amplifier, H parameters. Current gain, see in the previous slide we discussed commonly for all the configurations. Now we will see in terms particular session. Current gain, A equals to minus HFE. For CE amplifier, the current gain is equals to minus HFE. What is HFE? HFE is the forward current gain, it is in negative. We know that it is 180 degrees out of phase. Input impedance RI equals to HIE, and the voltage gain AV equals to AI into RL by RI. Voltage gain AV equals to AI into RL by RI. RI, we know RI is equals to HIE. Input impedance is equals to HIE. So a voltage gain is equals to AI into RL load resistor by HIE. Output impedance Y0 is equals to Y0 is 0, that means R0 is equals to that R0 or Z0 is equals to 1 by Y0. When Y output impedance is 0, that means then R0 is very high. CC amplifier parameters in terms of common emitter H parameters. CC amplifier equations in terms of common emitter H parameters. AI, current gain is equals to, generally for CC current gain is equals to output by input. Output is emitter current I0 and input is base current IB. It is equals to minus IE by IB. It is in terms of CE H parameters. AI equals to 1 plus HFE, and input resistance RI equals to input voltage by input current VB by IB, it is equals to HIE plus 1 plus HFE into RL. Voltage gain AV equals to 1 plus HFE into RL by HIE plus 1 plus HFE RL, it is equals to 1. And the output resistance R naught is equals to output resistance is equals to output voltage by output current, it is RS plus HIE by 1 plus HFE. CB parameters in terms of common emitter H parameters. In terms of CE, H parameters. Current gain AI equals to HFE by 1 plus HFE, and the input resistance RI equals to HIE by 1 plus HFE. Voltage gain is equals to, generally voltage gain, it is equals to HFE by 1 plus HFE into RL by HIE by 1 plus HFE. It is HFE RL by HIE. Output resistance R naught equals to V naught by IC when Vs is 0. So here I am giving one example problem. You can solve with the previous formulas what we discussed. For the circuit shown in figure, estimate, that means calculate AI, the current gain, voltage gain, RI and R naught using reasonable approximations. That means you can take any assumptions. The H parameter for the transistor are, here the H parameters are given. HFE is 100, HIE is 2000 ohms, HRE is negligible, and HOA is 10 power minus 5 mhos, and IB, the input current, is 100 microamps. If you observe the circuit diagram, this is common emitter amplifier circuit. Common emitter amplifier that means you need to write the formulas of AI, AV, RI and R naught of CE amplifier. Just one I will explain. AI, what is AI? What is the formula for AI? AI is equals to, for CE, AI equals to minus HFE. What is HFE? That is given in the problem itself. That means AI equals to minus 100. Like that, take the note down the formulas first, then solve the problem. And that means calculate AI, AV, RI and R naught from these factors. Right. Okay. Before ending this session, just we will recall what we discussed in this video. Here we discussed about an amplifier. Initially, what is an amplifier? That means amplifier is an electronic circuit. It is amplifying, that means increasing the applied input signal, increasing the magnitude of the applied input signal without changing the shape and frequency of the input signal. And the feedback in this circuit is positive feedback. Amplifier can be designed with a negative feedback. What is feedback? Means taking the fraction of the output connecting to the input. Here what is negative means, again generally we know the positive and negative. That means in negative means there is a phase reversal between the feedback part and the input part. The positive means it is same phase. Amplifier is amplifying the applied signal. Again there is one condition to design amplifier, the transistor should be operated in the active mode, active region until for the complete input signal. For that means to make the transistor in to operate the transistor in the active region, the emitter input section should be in biased such that it should be forward, and output should be biased such that it should be in reverse. And small signal amplifier, CE amplifier we discussed. CE amplifier is a basic amplifier circuit. For it is called voltage amplifier. What is voltage amplifier? Means it is amplifying the voltage voltage signal. CA and all CA amplifier, and later we discussed about the H parameter equations as well as the H parameter equivalent circuits for CA, CB and CC. H parameter generally the H parameters are for a two-port network. H parameters are the basic parameters, simple parameters. Now we know the equations for H parameters for a two-port network. V1 equals to H11 I1 plus H12 V2, and I2 equals to H21 I1 plus H22 V2. From this we got the H parameters for CA, CB and CC. And after that we discussed about voltage gain, current gain, input impedance, output impedance equations in terms of H parameters. In terms of H parameters. In the next video we will we will analyze the CE amplifier circuit in detail from the two H parameter equations, and we will get the equations. In this session we will discuss only the equations, that means formulas. In next video I will explain how we got those formulas in detail. Just before that, just try to solve this problem. Just thank you. With this session I am I am ending this topic. Okay, thanks for listening.